Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 12 students who are studying trigonometry and advanced functions. In this video, I'll introduce you to radian measurement and we'll learn how to convert between radians and degrees. So first, let's talk a little bit about degrees because it's important that you know why we don't use them anymore. This diagram shows us the measurement of 1 degree. So it's a very small little itty bitty angle right in here between those two lines. I can't even really color it in. Or you can also say that's 1 rotation by 1 degree. That's a rotation by 1 degree. But why is this tiny little bit 1 degree? Well, the answer is because someone long ago decided that a full circle would have 360 degrees in it. In other words, we should be able to take a full circle and cut it into 360 equal little wedges, and each one of them is a degree. So really, 1 degree is 1 degree because it's 1/360th of a full circle. But that doesn't really tell me very much. What I want to know is, why is a circle 360 degrees? Well, the problem is that it's not a natural number that's inherent in any circle. It's a value that was kind of decided upon thousands of years ago that doesn't have any inherent nature within a circle. And the reason why that's important is because when imperial measurement started to give way to scientific measurement, things like meters instead of feet, and Celsius temperature instead of Fahrenheit, etc., the scientific world wanted to find an angle measurement that was also more natural and not arbitrary. So we don't want arbitrary measurements. We want a natural measurement. And so that's where the idea behind radians comes from, is it's a natural measurement inherent within the circle, and let's look at where it comes from. So, a radian measurement. Well, let's talk about the radius of a circle. It's the most important dimension. In fact, it's the only dimension in a circle. Knowing the radius tells you everything you need to about a circle, like area and circumference. So maybe by using the radius, we can also find out about rotation within a circle. And that's how they developed the measurement of a radian. What they did was they took this radius, measured it perfectly, and then trace the exact same distance along the circumference of the circle. So there it is there. This red line is exactly the same length as this black line. So this radius is the same length as this arc length. And no matter what circle you're looking at, anytime you do that, you're going to be creating an angle by that arc. And that arc, when that arc is exactly 1 radius in length, then the angle that it subtends is defined now as 1 radian angle. So this distance here is 1 radian because it's exactly the distance, it's exactly the angle created when the distance of 1 radius is traced along the circumference of a circle. That's what 1 radian is. And so that's a much more scientific and natural measurement, because it's not based on some ancient Sumerian or Babylonian people who just picked a number that they liked. That's what 1 radian is. Now, the important thing about 1 radian is that not so much that this is 1 radian and it's, however many degrees that is, 57 point something. What's important is that no matter how big or small the circle is, 1 radian is always constant, otherwise it wouldn't make sense. So here's the radius. Here's the radius of the circle, and here it is again traced out along the circumference. And so this is exactly 1 radian, a smaller circle, exactly the same. Here's the radius length along the circumference, and that's exactly 1 radian. It's the same no matter what. But what's really significant is what happens when we start to say, okay, what are some of the important measurements in radian form? So for example, important measurements, we know that a full circle is important. So how many radians are in a full circle? Well, we're going to answer that by looking at what's in a half a circle, just because, well, you'll see. So let's look at what a radian is. So I'm going to roughly draw 1 radian angle right here. So this is about 1 radius in distance, and that's 1 radian. And so from here to here, I'm going to measure another radian. I'm just kind of eyeballing it. There's another radian. So now I'm at 2 radians. So this distance would now be 2 radius lengths. And if I trace out yet another radian, so from here, let's rotate another radian about here. So now this is 3 radians in total angle. And along the circumference, I've now traced out 3 radius lengths. So you'll notice that there's no way I'm going to be able to fit another perfect radian in here. So there isn't some lovely integer value as to how many radians fit into half a circle. And therefore there isn't a nice value here. But the number of radians that perfectly fit into half a circle is a constant. No matter how big or small my circle, I will always be able to fit 3 and a little bit more. And that little bit more is about 0.14159. Does that look familiar to you? It should. Because in fact, there are exactly pi radians in a half a circle. And therefore, there are exactly 2 pi radians in a full circle. So most of the time when we talk about radian measurements for angles, we talk about what portion of pi an angle is, not really decimal radians. I've got a nicer picture over here just in case that really messed up. And just quickly again, this is 1 radian, this is another radian. So here's 3 radian measures right here. So there's a little bit left over, and that little bit left over is exactly, well, not exactly, but it's about 0.14, more precisely 14159, etc. In other words, there's this angle here in radians is pi. There's exactly pi radians in half a circle. And again, we know that because we know that the circumference of a circle is 2 pi times the radius. And so half of the circle would be pi times the radius, or pi radians. Kind of neat, right? So let's look at what the really important angles you need to know. Obviously, you need to know that half a circle is pi, and therefore a full circle is 2 pi. Those are measures you should know. So obviously we still like right angles, we just don't call them 90 degrees like we used to. So how many radians are there in 90 degrees? Well, there's pi radians in a half circle, and we're halfway there, so it's half of pi, or pi over 2. So this, if I start here and I rotate here, I've rotated by pi over 2 radians. So this would be 2 pi over 2 radians, which is just pi. This would therefore be 3 pi over 2 radians, and this would be 4 pi over 2 radians, which of course reduces to 2 pi. So make sure that you're keeping track. The radian measurements that are important are pi and 2 pi. Also, pi over 2 and 3 pi over 2 are very important. And then if I sort of clean this up a little bit, not only do we want to know about pi over 2 and pi and 3 pi over 2 and 2 pi, we also want to talk about what happens if I rotate sort of halfway to a right angle. So halfway to a right angle is half of this. So half of a half is a quarter, and you can visually see that I've gone a quarter of the way to half a circle, which means I've gone a quarter of the way to pi, or pi over 4. So this angle, which we used to call 45 degrees, is pi over 4. So this is another pi over 4. So we could say 2 pi over 4, but that just simplifies to what we already know. So I've got 1 pi over 4, 2 pi over 4. This would be 3 pi over 4. And then of course this would be 4 pi over 4, but that just reduces. And you can keep going. if this is 4 pi over 4 and I go by another quarter piece, like it's a quarter of a half, but still, this would be 5 pi over 4. 6 pi over 4, hey, I already know that. 7 pi over 4 and 8 pi over 4. So, and don't worry, I'll summarize this in a bit, but those are some really important angles that you need to be aware of when you work in radian mode. So you need to be aware of angles like pi and 2 pi because they represent half circle or full circle rotations. Pi over 2 and 3 pi over 2, well, those represent 90 degree, oh, I can't stop saying it, right angle or quarter circles of rotation. And then pi over 4 is that lovely half of a right angle. I don't want to say 45 degrees, but I just did. Pi over 4 is obviously important. Other important angles you need to know, if we now take this half circle, which we know is important, and we cut it into thirds, because think about what this would be back in degrees, right? That's obviously important. So if I take pi and I cut it into thirds, then what is this measurement? Well, this measurement is 1/3 of pi. 1/3 of pi, or pi over 3 radians. So this is 1 pi over 3. This angle here would be 2 pi over 3. And this would be 3 pi over 3, but we just reduce it to pi. So pi over 3 is also an important angle that you're going to need to know about. And it's not the last one, but it almost is. The other angle you need to be comfortable with, again, if I put back pi over 3, and now I'm going to cut each of those into half. So what I've really done is I've taken pi and I've cut it into 6 pieces. Each of these pieces is an angle that we look at a lot. And that angle used to be called 30 degrees, but now it's called 1/6 of pi radians. Well, pi over 6 is what I meant to say. So it's pi cut into 6 pieces. So this is pi over 6. And again, if we follow this pattern, this is pi over 6. If I go another pi over 6, then I'd have 2 pi over 6. Oh, so just pi over 3? Yep, we already saw that one in my last drawing. 1 pi over 6, 2 pi over 6. This would be 3 pi over 6, which reduces to pi over 2, which we already knew. This one would be 4 pi over 6, which reduces to something we already had. And this one, 1, 2, 3, 4, 5 pi over 6. And then it's 6 pi over 6, or just pi. So really, there's a lot more about this idea in my videos on actually doing trig with radians. I just wanted to give you an idea about why we like radians so much. Because you'll notice all of the math I just did was by counting. I went pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. And then I just reduced my fractions. So it's really easy to work in radians if you're using exact radians like this. So just to review and make a summary, what I call the super special angles are the angles that lie directly on the XY axis or at the right angle moment. So obviously 0 radians, pi over 2 radians, and pi radians are really important. And I'll put 3 pi over 2, even though that's just the next one in the pattern. But these are your super special angles that you need to know. As well, the special angles you need to know. You need to know about pi over 4. You need to know about pi over 3. And you need to know about pi over 6. And so I'm just going to put it here just for the last time, say goodbye to these measurements. But just in case you're wondering why these are so special, is these are the measurements that you're more comfortable right now calling 45 degrees, 60 degrees, and 30 degrees. So they're the angles that we're most familiar with, that are the most common to occur. So we need to be able to convert between degrees and radians. And in order to convert, we need to remember this relationship, that pi radians is equivalent to 180 degrees. And that gives us these formulas that if I have degrees and I want to translate into radians, I'm going to take the number I have and multiply by this conversion ratio. Because this conversion ratio is really the number 1, because pi radians is 180. But what it's doing is it's introducing radians on top and removing degrees. And that will convert us between degrees and radians. And then if I want to go the other way, to convert from radians to degrees, I take this conversion and I flip it upside down, so I introduce degrees and remove radians. So let's look at how to do that math really quickly. So if I have 240 degrees and I want to write that in radian form, I need to introduce radians and get rid of degrees. So that gives me a fraction of 240 pi over 180. And so all I want to do now is reduce 240 over 180. I want to leave pi in there so that I leave it in exact form. So 240 over 180, well, 24 over 18, they're both divisible by 6. So these are both divisible by 60. So that would be 4 pi over 3. Now, if I did want it in decimal form, this is where I would just take my calculator and I would type in 4 times pi and then divide by 3 and get whatever the decimal of that is. But I don't, normally we just leave things in exact form when we can. And then let's practice going the other way. If I have a radian measurement like 5 pi over 8 and I want it in degrees, then I need to introduce degrees and get rid of radians. So what that means is that this pi in the numerator will cancel this pi in the denominator. So I'm really going to have 5 times 180 times pi over 8 times pi. So the pi's are going to cancel, boom, boom, and everything else is just calculate 5 times 180 divided by 8. Uh-oh, I wonder if you're hearing those noises. I don't know what that is. So that would be 300 degrees. Really? Hold on. Sorry, that's 112.5 degrees. I had a feeling it wasn't 300, just because I kind of know. So there, that was a brief introduction into radians. A quick look at the important measurements in radians, like pi over 2 or pi over 4, so that you know what to look for, but mostly just an introduction to radians and how to convert. Okay, thanks very much. See you in the next video.